Let us see example 5, which is question number 47-48 from your textbook. Find the derivative of the integral of root 4t plus 9 dt, where t from 3 to 6x minus 1. Here we have the variable t, here we have x, and here we have x. So this will be, we will do the application of the fundamental theorem of calculus, which is the derivative form. But here we have 6x minus 1. So either you use the substitution replacing u by 6x minus 1, then you change d over dx by d over du multiplied by d over dx, or you will take this one replacing t by 6x minus 1 and du multiplied by the derivative of 6x minus 1. So let us do the both steps. So for the first one, if we assume u is equal 6x minus 1, that means du is equal 6 d of x. So now if we rewrite this one, it will be, so we replace d over dx by d over du multiplied by d over dx. Now we have the integral of 4 square root of 4t plus 9, where t from 3, replacing 6x minus 1 by u. So now this form is as the original form of the fundamental theorem of calculus. This will be the same function, which is root of 4, just we replace t by what is u. So we get here 4u plus 9 multiplied by du over dx. What is du over dx? So du over dx is equal 6. So this will be equal square root of 4. U is equal 6x minus 1 plus 9 multiplied by du over dx, which is 6. So we'll get this 4. Or directly what you will do, you will say that square root of 40 plus 9. You will replace this 1 by square root of 4 multiplied by 6x minus 1, then you multiply by the derivative of 6x minus 1, which is 6. So we'll get 6 multiplied by square root of 4, 6 multiplied by square root of 4, 6x minus 1 plus 9. يعني يا اني استخدم اللي هي اليو سبستيوشن هذه اللي سويناها الحركة هنا، او اني على طول بشيل هذه بعوض التي ب 6x minus 1 بالاضافة الى ان اضربها في مشتقة 6x minus 1 اللي هي 6. طبعا بيطلع لنا نفس الناتج. Similarly for this one, here we have derivative of integral of sine t square, where t from pi to root x. So again here we have root x, not x. So we need to use the u substitution. So if u is equal root x, so that means u is equal half x power minus half d of x. So now if we replace d over dx by d over du multiplied by d over dx, replacing root x by u, so we'll get integral of derivative d over du integral of sine t square dt, where t from pi to u multiplied by d over dx. For this form, it is as the form of the fundamental theorem of calculus. So this will give us sine u square. We replace t by u, so we'll get sine u square multiplied by du over dx. What is du over dx? We see that du over dx is equal half x power minus half. So we're replacing now sine u square, we say u is equal root x, so that's mean u square is equal x. So we'll get sine x multiplied by du over dx, which is half x power minus half. So the final result will be 1 over 2 root x sine x. Then we have example number 6. Use the fundamental theorem of calculus to find the derivative of fx. So here we have fx is equal integral of 1 over t cubed plus 1, where t from 3x to x squared. Here we ask to find the derivative, so we need to find f prime x. So it will be d over dx of integral of 1 over t cubed plus 1, where t from 3x to x squared. We cannot apply the fundamental theorem of calculus directly here, because here we have to have the constant, then here we have the variable x. So first we will rewrite this function as a function integral of two functions. So let us see. So we know that f prime x will be the derivative d over dx of the integral. So since it is 3x to x squared, so we'll take it from 3x to 0, then from 0 to x squared. Because if you add these two integral, it will be 3x to 0, then plus the integral from 0 to x squared will give you the integral from 3x to x squared. Now here we have from 3x to 0, but the fundamental theorem of calculus, it says from a to x. So we need to interchange this one to put it from 0 to 3x. To swap this one, to put it from 0 to 3x, we have to multiply by negative. So this will be minus integral from 0 to 3x plus this one will be okay because it is from 0 to x squared. Now we need to apply the fundamental theorem of calculus, but here we cannot apply directly since here we have 3x, not x alone. So either you take u is equal 3x, then you will choose that du is equal 3 d of x, and for this one you will choose, for example, z is equal x squared and dz will be 2x d of x. Or you from here directly you will replace t by 3x and you multiply it by the derivative of 3x, which is 3. Similarly, this one you will replace t by x squared and you multiply it by the derivative of x squared, which is 2x. So if you for this one, if you take and replace t by 3x, so it will be, here you have negative, so minus 1 over 3x squared plus 1 multiplied by, what is the derivative of 3x? Will be 3 plus. For this one, 1 over t cube plus 1. So you replace t cube by x squared cube. So it will be 1 over x squared cube plus 1. Then you multiply by the derivative of x squared, which is 2x. So it will be 2x over x squared power 3 plus 1. So now if you add these two terms, you will get it will be equal to x over x power 6 plus 1 minus 3 over 27x cubed plus 1. Then for number 50, f of x is equal root t squared plus 1 dt, where t from sine x to 5x. Also, we need to find the derivative of this one. But here we have two variables. Here we have sine x, here we have 5x. So we need to apply the fundamental theorem of calculus. Also, we'll use the two integral. It will be sine x to 0, then plus from 0 to 5x. So this will give us f prime x is equal d over dx, sine integral of function t sine x to 0 plus the integral of the function from 0 to 5x. Because if you add these two, you will get, it will be the integral from sine x to 5x. For this one, here we have sine x to 0. In our fundamental theorem of calculus, we have from a to x. So we need to interchange this one, so it will be minus the integral from 0 to sine x root t squared plus 1 dt plus. This one will be okay, so we'll put it the same. So again, if you use the substitution, u is equal sine x, du is equal cosine x d of x. For this one, if you assume z is equal 5x, that means dz is equal 5 dx. So now you will replace d over dx by d over du, you multiply by d over dx. And you replace sine x by u, so we'll get minus integral of root 2 t squared plus 1, where t is from 0 to u, multiplied by d over dx plus. For this one, you will replace d over dx by d over dz multiplied by dz over dx. And here you replace 5x by z. So you have derivative of integral of root 2 t squared plus 1, where t from 0 to z. So now this form as the fundamental theorem of calculus, this form also as the fundamental theorem of calculus. Now, so for this one, it will be minus, where you replace t by u, where u is equal sine x. So it will be minus root sine square x plus 1 multiplied by du over dx, which is the derivative of this one, cosine x plus. For this one, you will replace t by z, where z is equal 5x, so it will be root 5x squared plus 1. You multiplied by dz over dx, which is 5, so you multiplied by 5. So this will give us, it is equal to 5 root 25x squared plus 1 minus cosine x root sine square x plus 1. Then we have a substitution in a definite integral, which is Theorem 5.5.3. Let u is equal g of x be a function that has a continuous derivative on the interval a to b, and let f be a function that is continuous on the range of g. If f prime u is equal fu and c is equal g of a, d is equal g of b, then the integral of f gx multiplied by g prime x, where x is from a to b, is given by, we say that p is equal g b. So here we have replacing p by gb, replacing a by g a. So the integral of f gx g prime x will be the integral of fu du, where u is from ga to gb. We said that this one is integrable function and the antiderivative is f. So this will give us fd minus fc. So for the substitution in a definite integral, if you have a function, you want to use the substitution, also you have to change here the range of the integral. يعني لو مثلا عندنا function فيها الانتجرال بنستخدم مثلا اليو substitution. لما أغير الفانكشن هنا الجي of x باليو بتصير عندي جي اللي هي اف يو دي يو، لازم نفس الشيء أغير اللي هو الرينج مال الانتجريشن. يعني إذا كانت هنا بي لازم هنا بتتغير، بروح أعوض عنها بجيب قيمة الجي بي. إذا كانت هنا ال A نفس الشيء لازم أعوض عنها بجيب قيمة الجي. فإذا عوض في الفانكشن هنا اللي موجودة هنا لازم أعوض نفس الشيء وأبدل فيه الرينج مال الانتجريشن. Now we'll see an example to see how to apply this